Here's a question. You're given a messy string, and you need to pull a number out of the front. How would you do it? Think about something like a space, then a minus, then 0042. What's the right answer there? Okay, let's look at the example. One leading space, then minus, then 0042. The answer is negative 42. 4 things to handle in order. Skip spaces, read a sign, read digits, clamp to the 32-bit range. And 1 trap. If the digits make a number too big to fit in 32 bits, we clamp it, not error clamp. Okay, so first instinct. Strip the spaces, check for a sign, then call in on what's left. Easy, right? Try it on 1337, then C0D3. Python's int call sees a letter and throws an error. And the problem says read digits until a non-digit. We're not allowed to fail. We need to stop reading. Plus there's clamping. A huge number like 1 followed by 20 zeros should become 2 billion-ish, not crash. So the obvious tool is wrong. We need to walk the string ourselves, 1 character at a time. Here's the move. 1 pointer marching left to right, with a small state machine in our head. 4 phases. Phase 1. While we're sitting on a space, just step forward. Nothing to record. Phase 2. If the next character is a plus or minus, remember the sign, then step once. Otherwise assume positive. Phase 3 is the heart. While we see a digit, fold it into a running total. Times 10 plus the new digit. You might be tempted to collect digits into a substring, then convert at the end. Don't. We need to check overflow while we build. After each step, if the running total has crossed the limit, clamp it right there and stop. That's the rule. Okay, let's walk it. Input is 1 space minus 0042. Pointer starts at index 0. Index 0 is a space. Phase 1 says step forward. Pointer moves to 1. Index 1 is minus. Phase 2. Set sign to -1, then step to index 2. Index 2 is 0, a digit. Result was 0. 10 times 0 plus 0, still 0. Pointer moves to 3. Index 3 is 4. Result was 0. 10 times 0 plus 4 gives 4. Step to index 4. Index 4 is 2. Result is 4. 10 times 4 is 40, plus 2 is 42. Pointer falls off the end. Loop ends. Multiply by the sign. -1 times 42. Final answer, -42. Notice what we did. 1 pass, 1 pointer. No substring, no exception, no second walk to convert. We touch each character at most once, and we hold just a few numbers. The time grows with the string length, and the memory stays flat. Okay, same logic, now in Python. Set up the pointer, sign, and result. Skip the spaces. Walk forward while the current character is a blank. Read the sign if there is one, and step past it. Default stays positive. Build the number digit by digit. Each loop, multiply by 10 and add the new digit. Apply the sign, then clamp into the 32-bit range with 1 min-max sandwich. And that's the pattern. Walk once, decide as you go. You'll see this shape every time a string hides a number.